program, Basic Lighting Webinar. This is the second of a three-part series to learn about the commercial lighting program. We have invited both current and potential business partners to attend this series. We typically reserve the webinars for existing business partners. In this case, current partners will get a refresher on program details and learn about some program changes that are being implemented soon. And for potential partners, you can become a new business partner by attending the entire three-part series. We will provide you with the program registration forms to complete the process. I will be your speaker for today. I'm Ken Littell of ICF International, an independent contractor to NYSERDA. I'm currently managing the commercial lighting and motor systems business partners programs for NYSERDA, and I've been in the lighting industry for over 30 years. I've had the privilege of working with ICF for the last 11 years, first as an account manager and now managing the program. Along with a team of account managers and program support staff, we can assist you with understanding and implementing the program as part of your business model. So before we actually go into the program itself, I'd like to poll the audience to see how many people have other staff sitting with you as you attend this webinar. So at this point, you should be able to see the poll that says how many people are attending the webinar with you. You have your choices of 1, 2, 3, 4, or 5. And so it looks like everybody's clicking in. This will be somewhat of an interactive webinar. This is the first of 3 polls that we're going to launch during the presentation. And so be prepared to provide an answer. It'll help us with planning and help us with understanding our audience as best as possible. So it looks like this is pretty quick. We've got about a 96% vote already at 33 seconds. That's the fastest I think I've seen it happen. So we appreciate everybody's input. We'll give it a few more seconds here. Okay, so let's share the results. It looks like far and away the majority of you are attending this webinar by yourselves, understood, and then a few of you have some colleagues with you. So again, we appreciate your input on this. Be prepared during the presentation for some other polls that we will be launching. And at this point, we're going to get into the actual presentation. So today's presentation is actually, like we said, the second in a 3-part series. If you attended last week, you learned about the program details as far as what kind of incentives were available, how they operated, and how you actually needed to submit documents for that. We're going to go into more details today about the actual technical metrics of the program, and we're going to find what the right light is for you and its building blocks. We're going to describe how business partners can participate in the program so you can increase sales and profits. And then we're also going to demonstrate some of the program tools. So what is the Commercial Lighting Business Partners Program? If you've been in the program before, you probably already know this answer. But if you've never joined the program before, then you don't know this answer. The program, the Commercial Lighting Program, is designed to promote the right light, which is called effective energy efficient lighting solutions that result in better lighted spaces and cost less to operate. The target commercial project size for this program begins at 1,000 square feet, and then we actually have no cap on the building size or the project size. This used to be 1,000 square feet to 10,000, and then 1,000 square feet to 25,000, and then the last iteration before now was 1,000 square feet to 100,000 square feet. But we have since removed the size cap, so you can go ahead and submit any size project that you wish. And that's the project size, not the building size. So if you're dealing with a 1,000,000 square foot facility and you're only going to do about 100,000 square feet for that project, you can submit just that 100,000 square feet. And how we do this is we create a partnership between NYSERDA and the lighting industry through a network of trained business partners. For those of you that are currently business partners, you are part of that network. For those of you that are becoming business partners, we welcome you to join us. So we'd like to define for you effective energy efficient lighting, and we're going to circle back with this photograph in a couple of minutes. But it is the National Audubon Society headquarters that was a qualified design project back in 2007. And you can see we have a lot of different lighting characteristics here that kind of fit the different qualities of the program. So what's the definition of effective energy efficient lighting design? We've defined this as lighting systems that are optimally designed to meet specific application and energy efficiency needs. The systems are easy to use, aesthetically pleasing, and enhance the visual capability of people using the space. And this is how NYSERDA has actually worked with industry players. We actually helped create this particular definition by working with an advisory committee early on in the entire process. So we do listen to your input. And so how do you come up with the right light? It's a combination of two basic things: proper selection of technologies and proper system design and layout. And when you combine those two, you get effective energy efficient lighting design. If you're going to use today's technologies, you can combine them with solid design principles that actually are going to lead to a more effective design as well as it being energy efficient. And it's just a simple equation of adding these two parts together. So how we get there is we have a number of criteria that the program follows to qualify effective energy efficient lighting projects. And we'll get into each one of these individually, but simply their color rendering index, luminous intensity or glare, mean illuminance, which is known to most of us as light levels, illuminance uniformity, and energy use, which is watts per square foot. And that's on the last of the list, but certainly not the least important. And these metrics are minimum measures of lighting quality, and it doesn't guarantee that you're actually going to have a quality installation. That's what we're going to have to help work with you to come up with the right designs. Fixtures using 4-foot linear T8 fluorescent lamps must be CEE qualified high-performance T8 lamps and ballasts or reduced wattage T8 lamps and ballasts. If you're using LED luminaires, they must comply with NYSERDA's existing facilities program for solid-state lighting policy. We're going to get into the details of what that is in just a couple of minutes, so you'll know what to deal with. So on the quality metrics, what's color rendering index? Simply put, it's a scale of 0 to 100 that rates lamps' effectiveness to render colors naturally. So you want to make sure that they look the way they're supposed to. Sometimes you might go into a retail store and pull a suit or a shirt off of the shelf, and you feel like you need to go outside to be able to look at it to see if it's the right color. Or you purchase a couch and you get home and you say, that's not the color I thought it was when I was in the showroom. And part of that has to do with color rendering index. For the commercial lighting program, a minimum of 80 CRI is required in most spaces. Storage, electrical, mechanical areas, closets, and parking garages are exempt from this criteria. And color rendering index is not usually found on the luminaire specification, the fixture specification sheet. It's generally found on the lamp specification sheet. The exception to that rule is more and more often we are now seeing the color rendering index on LED specification sheets. So be aware of those particular characteristics. Quality metrics. Continuing, we want to talk about luminous intensity, also known as glare. And what it is, it's a measurement of light, of how the light actually exits that luminaire at different angles. And you can see from this table and the graph on the right-hand side of the picture that they show at various different vertical and horizontal angles, and where those two angles intersect at the vertical angle is what we're actually looking at. So your luminous intensity for open offices, which are offices that are greater than or equal to 300 square feet, the luminous intensity for those spaces cannot exceed 300 candela at 55 degrees. With pretty much every other application, it should not exceed 600 candela at 65 degrees. We do allow for a 20% variant on that. So 300 candela, you could actually get away with using 360 candela, or for 600 candela, you could actually get up to 500 or 720 candela. Fixtures mounted higher than 15 feet above the floor are exempt from this particular characteristic. Now, continuing with glare control, there's another option. You can also use what we call a high-efficiency low-glare luminaire or a retrofit kit as designed or defined in the existing facilities program. And some of you might recognize this type of a luminaire It's something that's been around. We're now starting to see more and more solid-state lighting or LED luminaires that have those kind of characteristics. We're trying to evaluate them now. But to qualify as a high-efficiency, low-glare luminaire, the overall fixture efficiency must exceed 80%, and it must distribute the light at very high angles. So at least 15% of the light output, or zonal lumens, between 60 and 90 degrees must be, or 15% of it must be between 60 and 90 degrees. So 0 degrees is as you're looking straight down through the luminaire, and 90 degrees is looking straight out parallel to the floor from the luminaire. 1 unit equals 1 fixture with 1 or 2 lamps. This is one of the qualifications for a high-efficiency, low-glare with a single ballast in there. And it must also incorporate something called advanced lighting distribution and glare control. This is not a common basket fixture that you might be familiar with that used to have perforated louvers or perforated reflectors with a little bit of a mylar backing to it. The efficiencies on those old basket fixtures were actually quite poor. Somewhere in the 50s and 60s, that's the amount of light that was getting out of the fixture. So the high-efficiency, low-glare luminaires are actually much more efficient and do a much better job. This is also not your typical lens truffer. You don't want to use an A12 prismatic lens luminaire for this type of an application. So the next horizontal mean of luminance is the next quality metric. And what it basically is the light level, the foot candles, the average light level. We're not asking for a maximum or a minimum. It's the average light level in the space. And what we've done is we've taken the recommendations from the Illuminating Engineering Society handbook and incorporated them into the program. You can find the information for the different categories because not every space is the same. You can find this information on the metrics by space page, which is included in the application packet. We're actually going to look at portions of the metrics by space page in a few minutes. And to get to the average horizontal mean of luminance, you need things like initial lamp lumens, fixture efficiency, ballast factor, but those are not the complete story. You need to actually determine what the light losses are, so the maintained lumens, and that's what you're looking for horizontal mean of luminance. So some of the minimum target light levels that you might run into are, let's say, 10-foot candles for a corridor or hospital. I'm not going to go through every one of these individual lines, but one of the items that we like to focus on is 50-foot candles for a high school gym. Depending on what type of a gymnasium it is, it may require a different light level, so you need to be cognizant of that particular issue. When you enter things in the online application tool, you can actually use this kind of as a design tool because it will actually give you back information on calculated light levels. And what it will show you is if the light levels that you've come up with for a particular space are lower than they should be, you'll get a warning message like you do here, saying the current light levels is 22.4-foot candles, and it's outside the recommended range of 34 to 36-foot candles. Another quality metric is the luminance uniformity, which is basically maximum to minimum light levels on the work plane. You want to minimize as much as possible the high and low spots in that particular space, so there's not very dark spaces in between the luminaires. And how do we do this? We look at the spacing criteria. The fixtures actually must be laid out within the spacing criteria that's listed on the manufacturer's luminaire photometric report or specification sheets. And they're going to be different if it's anything other than a round fixture. They're going to be different along and across. And along is usually with the length of the lamps, and across is cutting through the length of the lamps. So that way you have two different dimensions. Even some of the newer round fixtures with LED sources actually do have along and across spacing criteria that vary, so you want to be careful of that. This spacing criteria, luminance uniformity, does not apply to accent fixtures. So if you have a decorative fixture or a track head or a wall wash type fixture, it doesn't apply to this particular for the program. Now, how does this work? So spacing criteria is 1.5 across the luminaire, and the distance from the fixture bottom to the floor, or the work plane, is 8 feet then 1.5 times 8 feet is 12 feet. So the center of the fixture, from the first fixture to the center of the next fixture, cannot exceed 12 feet across. We also want you to consider vertical luminance as part of the quality metrics. So horizontal luminance or luminance uniformity is based on the light output between the fixtures and the spacing criteria between the fixtures, but we want to be concerned about the fixture distance to the wall. I've seen projects over the years where somebody said, okay, I've got a 30-foot wide room, and I'm going to put 2 rows in there of fixtures, or 2 columns of fixtures in there, and we're going to come in off the wall 10 feet to the first fixture, and then we're going to go 10 feet to the next fixture, and then we're going to go 10 feet to the wall. Sounds logical. You're splitting up that 30 feet 3 ways between all those fixtures. But in most cases, that actually does not provide you proper illumination at the walls. You really can only use half the distance of the normal spacing between the fixtures when you're spacing to the wall. So if you're allowed 12 feet between the fixtures, center to center, you're only allowed 6 feet to the wall. And this will provide you relatively uniform vertical luminance. We should let you know that we do provide a 20% or 2-foot allowance on that. We do understand that the geometry of the rooms and the geometry of 2x4 ceilings or various different ceiling treatments may not allow you to work exactly within that spacing criteria. So we do allow about a 2-foot allowance. And so you can see we've used several of these different types of metrics within this space. You have a direct indirect luminaire for the general illumination, which provides very uniform light. It also allows them to use a lower light level. And then it has some valence lighting or cove lighting along the sides, which allows for some washing the walls, and it provides, you can see that's kind of a walkway out, like to the left-hand side. And then it actually has, if you can see, there's some task lights that are mounted to the top of the furniture, which provides additional illumination. So if you're having a low general illumination throughout this open office space, you can pump up the task light levels by adding that task lighting right on the furniture. And so what we want to look at here is bringing it all together with energy efficiency. And effective January 1st, 2015, projects must be at least 10% below the space-by-space lighting power allowances for ASHRAE 90.1 2010. So if you've been involved in this program for some time, then you know that there's been different numbers that we've worked with over the years. Currently, up until January 1st, we are working with ASHRAE IES 90.1 2007. These different numbers are basically dictated by the Energy Conservation Construction Code of New York State. The current program up until January 1st is operating under the 2010 Energy Conservation Construction Code, and then a 2014 supplement was just approved, and we are going to be implementing that on January 1st, and that moves to the ASHRAE 90.1 2010 from the 2007. We've also said that we're not going to pay people an incentive for meeting the energy code. That's something you should already be doing, but we've reduced these numbers by 10%, and we'll show you how some of that works. We also use a metrics by space page that you can refer to. We understand that you can't read this particular slide, but we will provide you the documentation so you can see what the metrics by space are. But this shows you how it all kind of comes together. So for a recreational gym, it must be 80 CRI. Currently, up until January 1st, 2015, following ASHRAE 2007, the watts per square foot allowance is 1.26 for a recreational gym. After January 1st, it'll be 1.08 watts per square foot, and it'll be a 30-foot candle minimum. And as we mentioned, we're currently, we will be following ASHRAE 90.1 2010, at least 10% below that. But in addition to changing some of the watts per square foot numbers for energy use, it also made some different modifications. So you don't have to be quite as concerned about the numbers dropping too low. there are considerations for spaces that have odd dimensions and have a high room cavity ratio. We'll discuss exactly how you calculate room cavity ratio in a second, but essentially these are spaces that have very long or very tall dimensions, and they have an additional RCR ratio, an additional 20% of lighting power allowance for a high RCR. Certain types of spaces will also allow for additional lighting power allowance for decorative or accent lighting. This is a totally separate number from the main general lighting power allowance, and we'll get into some of those numbers in a minute. And like we mentioned, we have the metrics by space page. You can actually look at that and find out what the list is for each and different space, what the lighting power allowance is for general illumination, what the lighting power allowance is for accent, and we'll also show you that we do have the RCR allowances based on high RCR numbers. All that said, business partners are still responsible for meeting all of the current codes, whether that's energy or NEC codes for any project. So room cavity ratio. For those of you in the audience who've actually looked at lumen method calculations to do them by hand, you've very likely run into this before, that RCR is a standardized way to quantify the room's proportions. And how you get there is you multiply 5 times the mounting height of the luminaire times the length plus the width, and divide that all by the area of the room, or the length times the width. And so that if the room has a higher RCR than a limit that we're working with from ASHRAE, then it's allowed an additional 20% for general illumination for that particular space. So for example, if you have a private office that's 12 foot 6 by 10 foot by 9 feet high, when you run through the calculation, it will have an RCR of 8.1. The room cavity ratio threshold for private offices under ASHRAE is 8. So since 8.1 exceeds 8, the standard lighting power allowance of 1 watt per square foot is increased by 20%. You get an additional lighting power allowance of 20%. So instead of 1 watt per square foot for that private office, you have 1.2 watts per square foot for the private office. It's harder to light those kind of high ratio spaces with the same lighting that you would for a standard type space. So this is the reason for having the additional lighting power allowance. How does this all come together? If you're dealing with different spaces and different sizes and have watts per square foot allowances for the different categories, it all comes together by looking at the different categories and collectively adding them together. So if the 2 private offices have 250 square feet at 1.2 watts per square foot, you're allowed 300 watts total for private offices, 990 for the open office, etc. As you can see, you get down to the bottom where the warehouse is allowed 4,300 watts. So the total allowance for the space is 6,492 watts. So we're not only allowing an additional watts per square foot for high RCR spaces, but we're also allowing you to meet the watts per square foot for the entire project rather than just for a specific space. So let's say your open office, you actually have 1,100 watts for some reason. As long as your total watts in the entire space or the entire project do not exceed 6,492 watts for this example, then you actually can qualify for that project. Restrooms are a tough one. A lot of times it's hard to meet the 0.88 watts per square foot required. So these are areas that we can look at collectively, and you can aggregate the total watts for the entire project. And so the metrics by space pulls all these details together. And what the chart shows is the space type, the commercial lighting program general allowance, the RCR threshold, the decorative allowance, the color rendering index that's required, the light levels and the glare control, and what occupancy sensors are required, or which types of spaces they're required. Obviously, you can't read this particular chart, so we're going to give you a little bit of a blow-up here, an enlarged version of a section of this. So you can see automotive service repair has a general lighting power allowance of 0.6 watts per square foot with an RCR threshold of 4. So if the RCR threshold or the RCR for that particular space was higher than 4, then you could get an additional 20% watts per square foot allowance for that particular space. For auto repair service specifically, there isn't an additional allowance for accent or decorative lighting. But there are other spaces like banking activity areas where you have accent lighting allowance, decorative spaces, etc. The bottom table here, which is on the metrics by space, also reminds you of some of these other rules, like the 20% variant that you get for the additional RCR, the gymnasium light level that you want to look at the IES requirements or recommendations for the different types of gymnasium spaces, whether it's an NCAA type of space, whether it's just a recreational gym at the YMCA or your local exercise facility, or whether it's a high school gym. They all have different lighting allowances or light level requirements. Controls. And we're going to go back a second. As you see on this far right-hand side, we talk about the controls required. So if it has a yes in that particular column, then it tells you that you have to have an occupancy sensor or a dimmer in that space. For example, private offices, conference rooms, break rooms, warehouses, and restrooms and classrooms all require automatically shut-off controls when the space is vacant. This does not mean necessarily that every luminaire or every lamp in the space is controlled by an occupancy sensor or a dimmer. For example, in warehouses, you might have a 6-lamp luminaire, and you don't really want to turn off the entire luminaire so that the entire space is black. You might want to just turn off 4 or even 5 of the lamps and leave the others on, leave the other one on all the time. Or there might be an area that's more of a shipping area that's not necessarily an on-off type of an application. So in those cases, we allow you to not necessarily connect every single luminaire in that space to the occupancy controls. If you have any questions about how that particular category gets handled, you can contact your account manager or contact our staff here, and we can help walk you through the process. So again, sensors should always be considered in private offices, restrooms, conference rooms, and there's different types of sensors available. You have wall-mounted, ceiling-mounted, corner-mounted, and fixture-mounted, also known as integral. And there's actually financial incentives available for your customers under other NYSERDA programs. We're not going to get into a lot of the details of the other NYSERDA programs today, but for example, I think there's a $20 incentive for a wall-mounted sensor for replacement and a $50 for a ceiling-mounted. Dimming controls require that you might have a dimming ballast for fluorescent and HID applications. If you want to have continuous dimming or full-range dimming, which goes from 100% down to as low as 2%, you can do that with many of the different light sources. Some light sources don't allow you to get down that low if you're still trying to dim HID sources. Even some of the fluorescent sources don't allow you to get down that low. Some of the LEDs, you need to be careful about proper coordination between the dimming equipment and the actual dimmer. They don't necessarily always coordinate well. If continuous dimming doesn't work well for your application or is getting a little bit expensive, then you can consider things like step dimming. So going back to the warehouse application with 6 lamps, you could conceivably have 2, 2, and 2. So you could have 100%, 67%, 33%, and all off as various different light levels. And dimming saves energy and allows the applicants to tune their light levels to what their specific needs are for their relationship to the source, or if there's a lot of daylight in that particular space. We do actually have an advanced controls presentation that we go into. Some of you may have attended in the past that gets into the deep details of daylighting and daylighting controls, and we can talk to you about those if you're interested. So you might also, on controls, see complete energy management systems or subsystems for lighting. And they can actually integrate the time of day settings with the vacancy sensors and other features of the dimming systems. One example might be to have various different presets for cleaning crews. So if a cleaning crew is coming in at 8 o'clock at night and the office has basically been shut down since 6 o'clock, then the lights can be controlled for that short period of time while the cleaning crew is in the space. Today, we're seeing a lot more with wireless technologies for controls so that you can actually, without having to rewire a luminaire, add a module and be able to control that from some kind of a wall switch that has a wireless receiver and transmitter. The initial cost might be a little bit higher, but the overall installation cost of adding wireless technology to a particular space may be much less expensive than trying to rewire. And now there's also self-commissioning units that allow you to do daylight sensing by just going in, setting it all up, and it will actually self-commission itself over time. So, why are we doing all this? Why do we set all these features in place? It does cost a little bit more money to put all these products together, and what you want to know is that there's a cost for light. So once you've actually installed the product, there's a 4% cost for maintenance for lamps, an 8% cost for labor to maintain the lamps and the ballast. So if there's no ballast, maintain just the lamps. And then the rest of it, 88% of the cost of operating those luminaires after the first cost, is all electricity. So if you can reduce a few watts on an individual luminaire, you're helping to reduce the cost of operating every day of the week, every month of the year, moving forward. And so you want to create an energy savings situation, but you still want to provide the appropriate lighting for the solution. You can reduce the fixture wattage. You can use more energy efficient luminaires to deliver the light. So we talked about the high efficiency, low glare luminaires a short time ago. Those actually tend to be a very highly efficient luminaire. A lot of them are in the 90% range and higher. And this compares to maybe older technologies like parabolics that used to be around that were like a 60 to 70% efficiency instead of the current technologies of high efficiency, low glare at 90%. You want to design to the appropriate light level. Instead of having fixtures mounted every 4 foot on center, you can mount them out every 8 or 10 feet on center. This will allow you to use potentially fewer fixtures in the space and provide the correct light levels for the space. You want to control the hours of use either with sensors or dimming or other types of control systems. And this will provide better energy savings. But the right light doesn't actually have to be expensive. This particular photograph in here is for Bare Bones Furniture. Some of you that are in North Country up in New York might know about Bare Bones. They've got multiple locations. And this was a job that was done a while ago where they actually had rows and rows of continuous fluorescent luminaires. And they went to individual luminaires, as you see here now. And it was actually done for under $1 per square foot. And it was saving them about $4,000 in energy costs every year. One thing that's hard to pick up in the photograph is to reduce glare from the industrial fixtures. We actually had louvers installed on the bottom of those luminaires. But, you know, a typical industrial luminaire is maybe a $45 to $55 luminaire for a 2-lamp fluorescent, as opposed to it being, you know, a $200 fancy fixture. So it's not necessarily something that has to be expensive. In addition to that, you should be aware that all the table lamps, there's only one in the, there were a couple of them in the photograph. The table lamps actually were, at the time, changed over to compact fluorescent. Today we'd probably do that with LED, but it shows that they were trying to be energy efficient throughout the space. So what are some of the replacement options? For those of you that are looking at this table for the first time, you might say, this is an entire fluorescent table. Why aren't there any LED stories here? This story carries through with a life cycle cost application, and we've actually challenged various different manufacturers and manufacturers reps to help us come up with a better cost scenario, cost saving scenario, and come up with the light levels we're talking about in this particular application. So you want to be aware of that when you're watching this. So for the time being, this is the example that we use. If you still have 3-lamp F34T12 fixtures existing in the space, there's a bunch of different options that you can use. And by the way, we do anticipate that there will probably still be about 7 to 8 million 4-foot 34-watt T12 lamps installed and operating in 2017. So this is still an issue. There's still quite a bit of them out there in New York State. You have different categories. You can change to a standard lamp with a normal ballast factor F32T8. You can go to a high-performance T8 low ballast factor, and that's the application that we're actually going to focus in on here, where you can go to a 3-lamp 0.77 ballast factor, which is a 73-watt system, and gives you about 6,800 lumens out of that entire system, which is considerably higher than the 6,200 lumens from the F34T12, and the lumens per watt of the high-performance T8 low ballast factor luminaire is about 93 lumens per watt. And this is a really good example of how you can make a change out this way. So if you looked at an existing 3,000 square foot retail space and the owner was looking for a 75-foot candle light level, they're probably only in the 60s currently. They wanted to know what their options were. So if the existing system's F34T12s, it's about 115 watts per luminaire, and they did have 60-foot candles there. The average everyday contractor or distributor or rep is going to come in and say, well, we can go to F32T8s, and that would be an 88-watt fixture, and it'd give them 78-foot candles. So they pumped up the light levels pretty well, did save them some energy, about $1,800, from $2,400, so about $500 a year. But we can go a step further by going to the high-performance T8 low ballast factor system, using a 73-watt luminaire, providing 76-foot candles, which will save about $900 a year from the initial 212 system. Today, we believe that there's applications where we can go from also to LED, but at this point, we're looking for the cost effectiveness of that particular application, and we're looking for information from people to help us. The cost of the fixtures at this point hasn't allowed it to get down into these kind of cost savings. And so you can actually evaluate this information through a life cycle cost tool that we have available to our business partners, where you can input the kilowatt hour rate. You need to look at somebody's utility bill. Kilowatt hour rates vary. If you were in upstate New York last year, it went up to 20, 25 cents in the middle of February and March, and then it went back down to 14 cents. So it varies. You want to make sure you're looking at what that is. But you can compare 3 existing or typical systems in this life cycle cost tool to 3 proposed systems, and you can provide this tool an output of actual energy savings, payback period to your customer. It'll show you things like the simple payback period, which in this case is 1.08 years, and annual return on investment of about 93%. It'll also show you the KW reduction and the greenhouse gas emissions reduction. And it also shows you not just the simple payback period, but it shows you the life cycle costs over a 1 to 20-year period. And this is a nice tool to be able to use for your customers to demonstrate how they'll not only be saving energy, but they'll be saving money over time. And how we calculate that is we have to capture things like the initial fixture cost, the lamp replacement cost, which also includes the lamp life and also the ballast life, the energy cost, how much is it going to cost per kilowatt hour, and put that all together, and we come up with the energy savings through the life cycle cost tool. So at this point, I'd just like to poll the audience to get an idea of whether or not you have or use a life cycle cost tool. And so we've set up the poll here. Do you currently use a life cycle cost tool in your project information to your customer? And so everybody's voting quickly here. We're up around 60%. Give it a few more seconds. 71% vote. Anybody else? Okay, the voting slowed down a little bit. So we'll give everybody a few seconds here. Okay, so this poll comes out that 48% of you are currently using some form of a life cycle cost tool, and 44% of you are not using a life cycle cost tool. I would suggest that if you're using some kind of a life cycle cost tool, whether it's ours or whether it's a manufacturer's or something you develop on your own, that this would actually help you to close the sale more effectively, because it actually shows you various different features of how this is going to save energy and money over time. And here's an example. You're talking about this 300 square foot project. If somebody came in with a standard T8 option, the initial cost of the project would be $3,745, and the contractor who came in with the high performance T8 option is $3,900, and they're sweating it out because they are concerned that that $245 difference is going to lose them the job. So this is where you bring in the life cycle cost information, and you demonstrate that the replacement costs are $1,916 for the standard T8 option, and they actually went down for the high performance T8 option. Why would they go down for a high performance T8 option, even though that's a more expensive source? Primarily because of lamp life. A standard T8 only has like a 20,000 hour lamp life, and we used for this calculation a 24,000 hour lamp life for a high performance T8. These days I know on the CEE list there are actually lamps on there with 50 and 75,000 hours of lamp life projected. And then the overall energy cost for 10 years using the standard T8 system to the high performance T8 system is actually, the high performance T8 system is about $3,000 less. So over that 10-year period, they're going to save $3,000, which far outweighs the $245 cost difference on the initial project. And so what it all boils down to is that $245 system difference between the standard T8 and the high performance T8 provides a $320 energy cost savings for the first year, and a simple payback on the difference between those systems is under a year, about 3/4 of a year. So that's a pretty quick payback period. So we've talked to you about the metrics. We've talked to you about selling this to your customer and showing them the life cycle cost tool. Let's show you a little bit about an application exercise. And we're going to get into some details about entering this information in the tool on our program next week. So you can go ahead and join us and show how this all goes into the online application tool. So the scenario here shows several private offices, a conference room, an open office. And when you're looking at the commercial lighting program, you need to think about how this is all going to divide up and how you're going to evaluate it for lighting power allowance, lighting power density, light levels, etc. And so you can see that the way you draw the line could make all the difference. In our example here, we show that we had a corridor area down along the bottom of the diagram of about 5 feet wide, because in that case, there really wasn't anybody working in that particular space, that 5 feet that's off the open office. But you could reevaluate that depending on whether or not maybe there's file cabinets there or other types of office furniture, maybe somebody's working along that wall. So maybe that really the entire space is open office. And this will affect how much wattage you're allowed and what kind of light levels you're allowed for these different types of spaces. So these are things you want to consider while you're evaluating and designing these particular projects. So LED seems to be the biggest buzzword these days. As of January 1st, 2011, NYSERDA started allowing various different types of LED products on their existing facilities and new construction programs, and they did create a solid-state lighting policy. And basically what that policy says is that if you're using some form of an LED luminaire, it's either got to be on the Energy Star or Design Lights Consortium qualified products list. As I mentioned at the beginning of the presentation, we will be handing out the slides, so you'll be able to get the links to all of these different locations so you can have direct access to these particular items and find what qualifies and what doesn't. So LED luminaires have actually come up with some there's been standardized testing developed through various different organizations, primarily the IES over the last few years. And we have IES LM70 and IES LM80, and these are basically approved methods for testing these luminaires. These are not methods for qualifying the luminaire. It's just a standardized method for going out and testing what kind of light output is coming out of that luminaire, the luminant maintenance of that luminaire. So if somebody comes to you and says, we have an LM79 and LM80 qualified LED luminaire, that really wouldn't be the case, because it's not a matter of qualifying it with LM79 and LM80. That's how they test it. So LM80 was measuring the luminant maintenance of luminaires, LED light sources. Later on, TM21 was introduced to be able to show a long-term projection. As you might know, LEDs have very long life, and a lot of them were projected as being 100,000 hours, and to test for 100,000 hours with only 8,760 hours being in a year would take about 10 years. So it needed to be a little bit more efficient method, and so now people can extrapolate on what the long-term lumen maintenance of an LED source is going to be using TM21. Some of the ENERGY STAR categories that are allowed are under cabinet lights and desk task lights, cove lighting and accent lighting, and downlights. You'll notice most of this tends to be a little bit more on the residential side, but the Design Lights Consortium does not qualify downlights, so really there's a crossover between commercial and residential on that category. So downlights are on the ENERGY STAR list and not on the DLC list. Design Lights Consortium has a lot of different categories. The last time I looked at the list, there were over 40 or 50,000 luminaires on the Design Lights Consortium qualified list. So it's a pretty big list to choose from these days. If you're dealing with a fixture that's not currently covered by ENERGY STAR or Design Lights Consortium and you need to qualify it, you need to check with us for the commercial lighting program, or you need to check with NYSERDA on the existing facilities program. So we've been talking about the right light. Let's pull it all together. What does it provide for your customer? What does it provide in the long run? Visual comfort. It helps to reduce eye strain and fatigue. Provides visual interest. In this particular application here, this is a banking facility in downtown Albany, and the ceiling fell down, so they had to replace the luminaires. And when they put in the parabolic fixtures that you can see there, did a really nice job lighting inside, but from outside you couldn't tell that the actual space was in operation. You couldn't tell they were open. They had saved enough energy costs so that they were able to increase their budget for the installation of product, and able to add these chandeliers and wall sconces, provide some additional visual interest and visibility from outside the store or outside the bank so that people could tell that they were on. And visual performance, there are a lot of different studies about productive workforces. We don't put the links in here anymore because they tend to move around over time, but if you're looking for a productivity study, get in touch with us and we can direct you to them. Less absenteeism. I haven't ever heard anybody call in and say, boss, I'm not coming to work today because the lighting's horrible. But that said, if you go to work every day and you don't feel right because the lighting's not all that great, then that's probably part of the reason might be the lighting. So if you can improve the lighting, you're going to have less absenteeism. And repeat customers. If you have a better atmosphere, a more comfortable space, better looking, better quality rendering or color rendering, then you're going to have a better chance of having repeat customers and sales. You can show these benefits to your customers. We actually have various different case studies that we've provided or produced that you can actually get electronically. We can get them to you on paper, whatever makes sense, and you can demonstrate them to you. Think about what case study or what project that you have out there that might fit into a case study category. And so that's pretty much what the program is all about as far as the criteria, the lighting metrics, and the life cycle cost tool. If you need to find some additional information, if you're looking for program information on the NYSERDA funding opportunities, you can go to nyserda.ny.gov. We also have links here for CEE on High Performance T8, also ENERGY STAR and Design Lights Consortium for the qualified product list for LED. And when we send the slides out to you, these links will all be live, so you'll be able to go right to these particular sources. So I have one more poll that I want to share with everybody before we wrap this up. What percentage of your lighting sales or design are currently LED luminaires? And we'd love to get everybody's input because this is kind of a moving target these days. Okay, we've crossed the 60% threshold of voters. We've heard different things from the industry that, you know, it's going to be 20% by 20 or 30% by 20. A lot of people telling us more. So we're just trying to get a feel from the audience as to what the reality is in the marketplace. So we've got about 73% voting, 76%. Give it a few more seconds. Does anybody want to make any additional vote? Once, going twice, and we'll go ahead and close the poll and share it with all of you. And I think to a great extent, this is pretty much what I expected, that 19% are saying between 20 and 30%, 12% or 20%. Actually, looking at this again, 54% of you are saying that it's greater than 50% of your sales. So I'm actually finding that kind of interesting. So I greatly appreciate everybody's input in the poll, and thank you for sharing that information with us. And so with that, just like to show you, in addition to all these contacts that we have, or links that we showed you on the last slide, you can reach out to the various different account managers across the state. When we send you the slides, the links will be available so that you can click right on them or call them and talk to one of the account managers. Or you can talk to us through the Commercial Lighting Program website, the lighting partners at NYSERDA.ny.gov, or we have a toll-free hotline that you can use. And I'm going to now take a look at the questions online. So if you have a question and you haven't typed it in, take the opportunity to go ahead and do that. At the moment, looks like I have two questions on here. Can controls which cap maximum light wattage output be utilized to meet watts per square foot requirements? That's a little bit tricky, because if it's a programmable control that somebody can come back and reprogram later, then you have the potential for losing that energy savings. So in general, the answer is no, but I won't completely close the door. If you have a particular case where something is locked out somehow, we can talk about it. The savings on LED T8 fixtures used in 8 hours or more per day compared to 32 watt is definitely better. The one thing that we've considered in this equation is whether or not it was meeting the particular light levels we were looking at and still being cost effective, having some kind of a payback. Understanding LED can get there as far as the light levels go, but the cost is not necessarily going to be faster. But we can certainly take a look at that. If somebody's got some numbers, I would be happy if you share it with us so we can revise our model that we use here. So I have another question, says, I never have used the NYSERDA rebate, so what is the rebate percent given when using DLC LED products? We did do a presentation last week that dived into the details of the existing facilities' performance-based and pre-qualified programs. The short answer for here is that if you use the pre-qualified program, there are specific pre-qualified specifications, like for downlights or for canopy lights, or for wall packs. If you meet those specific specifications, then you have X number of dollars per luminaire. So like for a wall pack or a canopy light, it might be a $200 incentive. For an LED downlight, it might be, this is off the top of my head, it might be $50. And then they have actual replacement lamp incentives. If you're doing it under the performance-based program, then it's not specific to the individual product, but it pays an incentive based on the kilowatt-hour savings for the 1 year. And it's 12 cents per kilowatt-hour saved for 1 year for pretty much all of upstate, and then Con Edison territory is 16 cents per kilowatt-hour. How can a prospective customer able to see how much the rebate will be before we begin the lighting program? So if you're using the pre-qualified program, if you confirm that the fixture meets the specifications that are listed there, that's pretty much the process. You look at the list. If it says it's $20, that's what they would potentially get. There is not a pre-approval process for the pre-qualified program, so there isn't an absolute guarantee there, but at least you can follow the list as long as your fixtures meet those qualifications. For the performance-based program, it does require pre-approval, and NYSERDA actually does have someone inspect on both the pre-installation and post-installation sides to confirm the energy savings, and then pays the incentive based on the entire amount. So through the pre-approval process, NYSERDA determines if what was proposed will meet that energy savings, and then will actually provide the end user with what they call a purchase order that says that, yes, we will pay you X number of dollars once the project is complete and confirmed for that particular incentive. So in that case, there is money sequestered for the particular project. Somebody asked how I can get the slides for the first presentation. With the slides that we send out for this particular presentation, we'll go ahead and send the slides out for the first presentation as well. That's all the questions that we've seen on the phone line today. I want to thank you all again for your participation. Again, this is the second part of the three-part series, and next week we're going to do a presentation on inputting the information into the online application tool for the commercial lighting program. So if you're interested in that, let us know, and we'll make sure you get signed up for that particular presentation. And with that, I thank you again all for joining us, and have a good day.